So welcome to this latest video on 162 Maths, and in this video we'll be reviewing the topic of surds before going through some exam style questions. Now, to go through each of these individual strands of surds, if you're not sure about, then I strongly recommend that you do watch the individual videos, and I'll include some links in the description below. And if you're wanting a copy of the questions that we go through in this video, then all you need to do is just simply click on the link in the description. Now, when revising surds, it's important that you understand 1, what they are, 2, the laws, 3, how to simplify them, and 4, how to work with surds through their use of other areas of maths. Now, surd is a way of writing what we call an irrational number, which is basically a number that cannot be expressed or written as a fraction in exact form. Now, exact form basically means that you've not rounded or it's not a never-ending decimal number. Now, this makes answers from calculations using surds more accurate, easier to write. Because they're not using rounded numbers, your answer is obviously therefore going to be more accurate. But generally speaking, a surd is a number that's written as a square root, but it works in exactly the same way as any other number or fraction. Now, to simplify a surd, you must know and be fluent with your square numbers. Now, typically speaking, it's kind of known that you should really know all your square numbers up to 1 to 16. Anything beyond that is probably going to be using a calculator, or again going beyond what students are expected to know. Now, once you're familiar with your square numbers, the next thing for you to do is to recognize that to simplify a surd, what you need to do is think of two numbers that multiply to equal that number, where one of the numbers is a square number. Now, ideally, you don't want to use 1 because 1 goes into everything. You can always write, and it's not really going to change the number or make it any easier for you to simplify. But you also want to try and think big, as just like with simplifying fractions, when you're writing equivalent fractions, the bigger you think, the easier the work is going to be, and the less work that you're going to have to actually write down in terms of your working out. Now, once this is done, the only thing you need to then do is simplify. Simply rewrite the original number as a product of these numbers and then simplify the square number. So for example, here we've got 5 possible questions, and these numbers tend to appear quite common when it comes to simplifying surds questions. So looking at question A, it says for us to simplify root 72. Now, from this list of numbers, if I just highlight all our square numbers, what I want to think of is which number excluding 1, so we can actually just get rid of that, so we just put a cross through 1. Then what we want to think of is which one of these square numbers is a factor of 72, and you want to try and think the biggest number. So 4 goes into 72, but is it the biggest square number? Now, the biggest square number, or the biggest factor of 72, that's a square number, is 36. So what I can do is I can write 72 as square root of 36 times root 2. Now, in terms of knowing my roots, I can simplify this because I know that this is root 6. Sorry, it's just 6. And root 2 can't be simplified, so that's just going to be root 2, leaving me with my answer of 6 root 2. Because just like the rules of algebra, we don't use the multiplication symbol, but the simplified answer is 6 root 2. If I then moved on to question B, let me choose the same colour pen. So with B, we've got root 50. So again, looking at the list of numbers, square numbers, I want to try and think which is the biggest square number that is a factor of 50. And hopefully you'd recognise that it's 25. So I can write this as root 25 times root 2. Root 25 can be simplified as 5, so that's 5 times root 2, leaving me with a final answer of 5 root 2. Then for C, again, I want to think I've got root 200. So again, out of the square numbers, which is the biggest number that goes into 200? So hopefully you'd spot that it's going to be 100. But let me just show you how this question differs. So let's just do this first of all. So that's going to be root 100 multiplied by root 2, which then becomes 10 root 2. Now let's say I didn't go for the biggest number, the biggest square number, and let's say I went for a smaller one. So I know that 4 goes into 200, so we can write this as root 4 times root 50. So this then becomes 2 root 50, but the problem with this is I can still write root 50 as shown in B, that I can write root 50 as a simplified surd. So then that then becomes 2 times root 50, which then becomes 2 times, and then if I go through the same process, that's going to give me 5 root 2, which then comes up to 5 times 2, which is 10, so it's 10 root 2, which you could see is the same answer as I got when I recognized that with this I can write this as root 100 times root 2, and that becomes 10 root 2. So you can see how I get the same answer. Then moving on to question D, so let me just quickly get rid of all of this so we've got a bit of space. So then moving on to D, we've got root 45. So again, which square number goes into 45? And that's hopefully going to be 9. So that's going to be root 9 times root 5, which then becomes 3 root 5. And there is my final answer. Then finally for E, oh, don't know why that's changed. Let's get the pen back up. And we've got root 20. So again, which of the square numbers is a factor of 20? Hopefully that's going to be 4. So it's root 4 times root 5. I can simplify this as 2. So then it becomes 2 root 5. And there is my final answer. So the next thing we move on to are the laws of surds. Now, there is a rule for multiplying and dividing, but there are no rules for adding and subtracting. So here we can go from, now with the laws, it's not always going to go from this side to this side. You could actually going in the other direction as well. So you could be starting off with root AB, and you need to split it up to root A times root B, which is exactly what we did when we went through some of the simple examples of simplifying. Now, when dividing, sometimes questions will use the division symbol, but sometimes they'll write it as a fraction. So this written here is exactly the same as this. And with surds, now when you've got square root on the top and the bottom, you can just square root them all as one thing. So that equals this. So again, and the same thing applies. Not only is this equal to this and vice versa, but this is also, the pink is also equal to that one, but also equal to that one as well. So there's always different ways in which you can write it, but hopefully you recognize that they are the same thing. Now, when it comes to adding, subtracting, these two things here do not work. So when you are adding or subtracting, so let me just write this down. So when adding or subtracting, the mentality that you want to try and think of is think collecting like terms. Now, an example of what I mean by this is if I had root 50 plus root 8, then that's not going to equal root 58. So it doesn't work like that. However, if I recognize that I can simplify these two things here, so root 50 is root 25 times root 2, which is 5 root 2. And I can simplify root 8 as root 4 times 2, so that becomes 2 root 2. Then what I can then do is, because they've both got a root 2, I can then just simply add the outside numbers together. So that then becomes just like terms. So just like, see this as 5x plus 2x. Well, that's therefore going to equal 7. We're not using x, instead we're using root 2. So it would be 7 root 2. Now, when approaching surds with large numbers, just like working with fractions with large numbers, your initial thought should be to try and simplify first. Now, this isn't essential, but it will certainly make any future calculations easier, so it's less likely to make a mistake. So looking at this first example here, so here we've got root 50 times 18. Now, yes, that does equal, using the law of surds, it does equal 50 times 18. However, 50 times 18 is going to give me a large number, which again, I'm going to have to do some long multiplying. In this case, not so much so, but in some cases it will do. So this will therefore equal root 900, and that then becomes root 100 times root 9, which is both square numbers, so that becomes 10 times 3, which is 30. Now a quicker way of me getting to that answer would be for me to recognise that root 50 is root 25 times root 2, which is 5 root 2, and root 18 is root 9 times root 2, which is 3 root 2. So then I've got 5 root 2 multiplied by 3 root 2, and so 5 times 3 is 15, and root 2 times root 2 is root 4, and that then becomes 15 times 2, which is 30. Now in some cases you might think what I've written in red was actually quicker. Some of you may think that what I did with the green and then the pink would be easier, but again it's all about your personal preference. And some questions it might actually be easier to go for the red option, but in other examples it might be easier to break and simplify the surds to make them easier to work with. Now again, this works with what we did here. So because there's no rule of adding, what I need to do is break the question up. So root 50, which seems to be a common number that we're using, what we've said is root 5 root 2, and root 18 is 3 root 2. So then adding them together, it's 5 root 2 plus 3 root 2, which gives us 8 root 2. Now the key thing to remember when simplifying and collecting like terms is you treat outside numbers as outside numbers. You can do that yourself, but in terms of the roots, they need to be the same when adding, subtracting. When multiplying, you multiply the outside numbers with the outside numbers and surds with surds. Try not to mix the two together. So for example, if I had 3 root 5 times, let's say 2 root 3, then 3 times 2 is 6, and 5 times 3, because they're surds, is going to be root 15. So the final answer is going to be 6 root 15. If I had, let's say as another number, let's go for 3 root 7 times root 5. So again, the outside number on the second one is a 1. So that's going to be 3 times 1, which is 3. And then root 7 times root 5 is root 35. Is there a square number that goes into 35? No, there isn't. So that there would be my final answer. Now the next thing we move on to is what we call rationalising the denominator. Now this will only appear on the higher GCSE, so if you're studying foundation you wouldn't really need to revise this particular topic, but obviously it's good practice for you to know what it actually means. Now rationalising the denominator is a very common question, but what does it mean? Well, it means write an equivalent fraction such that the denominator does not have a surd in it. Now the numerator, we're not bothered about what the numerator looks like. It could have 15 surds, it doesn't make a difference, but all we're wanting is to rewrite an equivalent fraction so that the denominator is not written as a surd. So for example, it's a bit like if we had the fraction of 18 over, let's go for let's say 15, so it's an improper fraction. So again, it's just a case of rewriting this fraction using smaller numbers. Now in this case, what we're going to do is we're just going to mess around with this denominator. We're not bothered about the numerator, we're only concerned about the denominator. Now how we do this is you do this by multiplying the numerator and the denominator by the denominator, but reversing any plus or minus signs you may see. Now in some cases there may not be any signs in the denominator, in which that's absolutely fine, but if there is, then just reverse it. So if you're not sure about what I mean, let's go through some examples here. So in these two particular questions, so here we've only got a single term in the denominator, which is a root 3. So what I'm going to do is, what's happened there? So here we're going to multiply both the numerator and the denominator by the denominator. So here our denominator is root 3. So I'm going to multiply that by root 3 and root 3 at the bottom. So then that becomes is root 3 and then 2 plus root 5. And then the bottom then becomes root 3 times root 3. Now again, we're not bothered about the numerator if that's got surds, but expanding the brackets out, we get 2 root 3 plus, and then root 3 times root 5 is root 15, all divided by and then a surd times a surd, we can do that, which is root 9. And root 9 is 3, so that becomes 2 root 3 plus root 15, all divided by 3. Now you might think at this stage, oh, I can cancel 3's out, but that's not going to be the case, because when simplifying, you can only simplify with the numbers outside of the surds. So this here would be my final answer. Now again, you might think to yourself, well, how does this look any different to this, because it just still looks like a mess? But the problem is that we've just rewritten equivalent fraction to 2 plus root 5 over root 3, so that we don't have a surd in the denominator, and that's all that we're concerned about. Now moving on to question B. So here we've got two terms in the denominator. We've got a 1 and we've got a 2 root 3. So again, I'm going to multiply by the denominator, but as you can see, I've got a plus sign. Now what I'm going to do, when I've got a plus sign in the denominator, I simply write the two terms. I've got 1 and 2 root 3, but instead of writing plus, which is in the denominator, I'm now going to write a minus instead. Then if I just put everything in brackets, what that then becomes is 4 minus 2 root 3 multiplied by 1 minus 2 root 3 all over 1 plus 2 root 3 and 1 minus 2 root 3. Now if you're familiar with quadratics, then hopefully you would spot that this denominator looks like a difference of two squares, and that's why this always works. So multiplying out the numerator by using loops, I end up with 4 times 1, which is 4. 4 times 2 root 3 is going to be minus 8 root 3. Then minus 2 root 3 times 1 is minus 2 root 3. And then minus times a minus is plus. 2 times 2 is 4. And root 3 times root 3 is root 9. So that's what my numerator looks like. Then the denominator, well, 1 times 1 is 1. Then 1 times minus 2 root 3 is minus 2 root 3. Positive 2 root 3 times 1 is plus 2 root 3. And then 2 root 3 multiplied by minus 2 root 3 is minus 4 root 9. Now from this, and this will always work in the denominator, is that these two things here cancel out, and this should end up being a simplified number. So that's going to be 4 times 3, which is 12. So then from this, what I can then do is simplify the numerator, and this becomes 4 times 3, which is also 12. So on the numerator, I've got 4 plus 12, which is 16, minus, then I've got 8 root 3, take away another 2 root 3, which that's going to give me 10 root 3 altogether, over, and then I've got 1 take away 12. Now 1 take away 12 is minus 11, so I've got 16 minus 10 root 3, all divided by minus root 11, and that there is my final answer. Now it might again look like an even bigger mess than what the original question was, but again, all we're looking at is equivalent fractions, and as you can see in my final answer, the denominator does not contain a surd. Even though the numerator does contain a surd, my denominator does not. The next thing for you then to do is just double check, can I simplify any of these? Now typically the surd won't usually cancel out, so I'm only looking at the numbers in that I've circled in green. So can I simplify 16, 10, 11? No, I can't. So that there would remain my final answer. So just to summarize, let's just go over the key aspects of what you could get asked in exam questions relating to surds. So the first one is basically simplifying surds. So this is when you're either rewriting a surd using smaller numbers or working with collecting like terms to collect them up. So for example, just be mindful that if you had a question of 3 root 2 plus 2 root 3, that this would not equal, you can't simplify this, and so that cannot be simplified. And the reason for that is because in order to collect the like terms, the roots need to be the same. So if I had, let's say on another example, let's say I had, let me just get rid of that, let's say if I had 3 root 2 plus 7 root 3 minus 5 root 2 plus 11 root 3, then I can simplify these two things, and I can simplify these two things because the roots are the same. And again, try and think collecting like terms. So 3 root 2 minus 5 root 2 is minus 2 root 2, and 7 root 3 plus 11 root 3 is plus 18 root 3, and there would be my final answer. The next common question is expanding brackets with surds. So this will either involve double brackets or single brackets, in which a single bracket question would look like root 3 or 2 root 3 times, let's go for 1 plus 3 root 3. And again, the key thing to remember when you're using your loops is you multiply numbers with numbers, surds with surds. So this would be 2 times 1, which is 2, so just going to be 2 root 3, plus, and then 2 times 3 is 6, and root 3 times root 3 is root 9. So that then becomes 2 root 3 plus, and then root 9 is 3, so that's going to be 18, and there is my final answer for that one. The next one is rationalize the denominator, which we went through, and again, you could either end up with one term in the denominator or you can end up with two terms in the denominator. But again, it's also linked with algebraic fractions, which moves on to the next one, but also quadratics as well. So just be mindful of those. 4 is working with fractions and writing surds as a single fraction. So again, this is heavily linked with algebraic fractions, which again, this type of question will probably now filter onto the higher syllabus, so only appear on the higher paper. And then the 5th one is work with other geometry topics such as Pythagoras, trig, area and perimeter, etc. Because remember, surds are just a number. It's just a more complicated way of writing a more sophisticated number. So when you're working with high level maths, you tend to find that the numbers are not going to be as nice, so may be written as a surd. And that kind of is a step up from working with negative numbers, decimal numbers or fractions. So now let's have a look at working through some exam questions. Now, there is no indication about whether these questions are calculator or non-calculator. So where possible, we'll just simply assume that they are non-calculator. And if they are appear on the calculator paper, it should be relatively easy because all I need to do is simply type it in and press equals. But you do find that even though surds questions do come up quite prominently on calculator papers, you still will be expected to show working out. So always have a look at how many marks are on offer, and if it's more than 1 or 2, then you probably will need to show some working out rather than just simply plug it into your calculator and press the equals. Now, a copy of these questions are available for you to have attempt at either before continuing watching this video or while watching this video, and all you need to do is just simply click on the link in the description. So looking at question 1, the question says, simplify root 15 to the power of 4. So let me just get a decent colour pen. So root 15 to the power of 4 is root 15 times root 15 multiplied by root 15 times root 15. Now with this, we know that this is going to equal, well, when I'm multiplying a root by a root, so it's basically root 15 squared, then the square and the square root will simply cancel, so that's just going to equal 15. And the same thing is going to apply for this, so that's root 15 squared, so that cancels with that, and 15 times 15, which is a square number which I should really know, and that's going to be 225. Alternatively, if you're not familiar, then all you need to do is then do some long division and you could work it out. But for one single mark, it'll be just explaining it. Another way of getting around this, a quicker way you may have found, is if I had root 15 to the power of 4, well, if I recognise that that's square root, then the square will cancel with 2 of the powers, just leaving me with 15 squared, which is 225. Then moving on to question 2, it says simplify root 96 over root 8. So again, what you want to do is recognise, now there's a couple of ways in which you can approach this question. So you could approach it by using the rule of surds, in which I've got a square root from both the numerator and denominator, so I can write that as 96 over 8. So then doing 96 over 8, if I divide that, well, 8 into 9 goes 1, remainder 1, and 16 divided by 8 is 2. So that's going to equal the square root of 12. So then from the square root of 12, I then need to think, well, what square number can I write that goes into 12? Well, that's going to be root 4 times root 3, which then becomes 2 root 3, which is exactly how they want me to write the final answer. Now another way of you getting the answer is by recognising that root 96 over root 8. Well, I can write 96 as root 16 times 6 over root 4 times root 2, which then becomes 4 root 6 over 2 root 2. Well, 4 divided by 2 is 2, and 6 divided by 2 is 3, giving me the same answer. The next one with question 3, it says root 18 times root 50, which is exactly the question that we did above. So again, I can write this as root 18 equals root 9 times root 2, which is 3 root 2. Root 50 is root 25 times root 2, which is 5 root 2. And then multiplying these two things together, well, 3 times 5 is 15, and root 2 times root 2 is root 4, which then becomes 15 times 2, which gives me my final answer of 30. Then when adding, again, root 20 is root 4 times root 5, so that's 2 root 5. And root 45 is root 9 times root 5, which is 3 root 5. Then adding these two things together, so I get 2 root 5 plus 3 root 5. So how many root 5s have I got? Well, I'm going to end up with 5 of them. Moving on to question 5, it says simplify 6 root 15 divided by 3 root 5. Well, if I write this as a fraction, I've got 6 root 15 over 3 root 5. Well, 6 divided by 3 is 2. And then root 15 divided by root 5 is root 3. So my final answer then is 2 root 3. The next one is looking at expanding double brackets. So here it's recognizing that root 3 plus root 27 equals root 3 plus root 27, root 3 plus root 27. Now with this, I know that I'm going to end up having to do 27 times 27, which is involving long multiplication. But if I recognise that root 27 can be simplified as a surd as root 9 times 3, which then is 3 root 3, and instead of writing root 27, instead I'm going to write 3 root 3. Now by doing that just makes expanding the brackets just that so much easier. So root 3 times root 3 is root 9, plus root 3 times 3 root 3 is 3 root 9, plus 3 root 3 times root 3 is 3 root 9, because you can only multiply surds with surds, and 3 root 3 times 3 root 3 is going to give me 9 root 9. Then simplifying all of this, well, root 9 is 3, 3 times 3 is 9, so let me just get rid of that, so that's going to be 9, plus another 9, plus, and it's going to be 9 times 3, which is 27. So then adding all of those things together, I've got 3 plus 18 plus 27 gives me an answer of 48, and that is, which is an integer. An integer is just basically a whole number. It then says for question 7, rationalize the denominator and simplify. So here we've got a single denominator, a single term in the denominator, so it's 24 over root 6. So again, I multiply by both the numerator and the denominator by the denominator. So that then becomes 24 root 6 over root 36. I can't simplify the top, so that's just 24 root 6, but I can simplify root 36, which is just 6, and then I can simplify 24 divided by 6, which is 4, so the answer then is 4 root 6. Then moving on to question 8, it says show that, and again here we're moving into algebraic fractions. Now when we are working with fractions and we're taking away, we need to make sure the denominators are the same. Now to get a common denominator, what I need to do is I need to multiply this fraction, the first fraction, by root 2 over root 2. So then if I multiply that by root 2, then this first fraction is then going to become 2 root 20 over root 6, and that's minus root 5 over root 6. Now because the denominators are the same, I can just simply take these two things away. So I've got 2 root 20 minus root 5 over root 6. Now the next thing then says I can then rationalise the denominator, but again I want to simplify first. So I can simplify root 20 as root 4 times root 5, so that becomes 2 root 5, which then this all becomes 4 root 5 minus root 5 over root 6, which then becomes 3 root 5 over root 6. Then if I multiply and rationalise the denominator, so I multiply by root 6, then that then becomes 3 root 30 over 36, root 36, which then becomes 3 root 30 over 6. Now can I simplify 30? Is there a square number that goes into 30? Just using my square numbers, there isn't. So then I can simplify that, the 3 and the 6, so that becomes root 30 over 2. So therefore my A value is going to be 30. Moving on to question 9, it says work out 2 root 30 times root 12 times root 90. So again, simplifying each of these, well, we get root 30 can't be simplified, so that's just 2 root 30. We've then got root 12, which can be simplified, so that's root 4 times root 3, which is 2 root 3. And root 90 is going to be, which square number goes into 90, and that's going to be 9 and 10, so that's root 9 times 10, which is 3 root 10. So then all of this then becomes 2 root 30 multiplied by 2 root 3 multiplied by 3 root 10. Now multiplying out the numbers outside the brackets, well, we've got 2 times 2 times 3, which is 12, and then we've got to multiply the surds, that's 30 times 3, which is 90, times 10, which is root 900. Now 900 is a square number, so I can rewrite this as root 9 times root 100, which is 9 times 10, sorry, 3 times 10 rather, which then becomes 30. So it's 12 times 30, and 12 times 30 is going to give me 360. Then moving on to a more applied question. So question 10 says work out the area of this rectangle. Give your answer in the form of something plus b root 2, where a and b are integers. Now working with this applied question, to work out the area of a rectangle, so the area is going to be the width times the height, so it's going to be 3 plus root 2 multiplied by 1 plus 2 root 2. So then multiplying out the brackets, I get 3 times 1, which is 3, plus 6 root 2, plus 1 root 2, plus 2 root 4. Then simplifying these, I get 3 plus, and that's going to be 7 root 2, plus 2 times 2, which is 4. So then that leaves me with 7 plus 7 root 2, and there is my final answer. Then moving on to question 11, it says simplify fully. So again, recognizing that root 160 is equal to 16 times 10, which is 4 root 10. So then the numerator then becomes 4 root 10 minus root 10 over, and then that's going to be root 10. So then from this, I get, simplifying the numerator, I get 5 3 root 10 divided by root 10, and the root 10s cancel, giving me a final answer of 3. Then moving on to question 12, it says, is the triangle right angle? So for this, if it's right angle, I want to use Pythagoras. So if right angled, then 3 plus root 3 squared plus 2 plus root 12 squared should equal 5 plus root 3 squared. So what I need to do is I need to work this out. Now, to make my life a little bit easier, I'm going to recognise that root 12 is root 4 times root 3, which is 2 root 3. So instead of writing root 12, I'm going to rewrite this as 3 plus root 3 squared plus 2 plus 2 root 3 squared. Now, what I need to do is I need to work out each of these separately. So first of all, if I do 3 plus root 3, 3 plus root 3, well, that's going to become 9 plus 3 root 3 plus 3 root 3 plus root 9, which is going to give me a total of 3 plus 9, which is 9 plus 3, which is 12, plus 6 root 3. Then if I then do 2 plus 2 root 3, 2 plus 2 root 3, I get 4 plus 4 root 3 plus 4 root 3 plus 4 root 9, which, adding all this up, well, that's going to equal 12. So 4 plus 12 is 16, and then I've got 8 root 3. And then working out what the hypotenuse or that diagonal is, which is 5 plus root 3 times 5 plus root 3, which is 25 plus, and it's going to be able to save a bit of time, so it's going to be 10 root 3 plus root 9, so that's going to be 28 plus 10 root 3. So then here, adding these two things together equals 28 plus, and it's going to be 8 plus 6, which is 14, so 14 root 3. So as these two are not equal, so the triangle is not right angled. So then moving on to, let's just move on to our last question. So it says, show that 7 root 2 minus root 8 squared simplifies to be an integer. So again, we've got 7, well, I can simplify root 8. So if I recognise that root 8 is root 4 times root 2, which is 2 root 2. So then what I could then do is right in the bracket, I've got 7 root 2 minus 2 root 2, which is going to be equal to 5 root 2. So then what it then becomes is 5 root 2 squared, which is 25 root 4, which is 25 times 2, which is 50, which is an integer, and there is my final answer.